To determine the answer, you should remember the formula of efficiency. Efficiency is calculated by the ratio of useful output energy and total input energy. If we want, we can convert to percentage by multiplying with 100. For this problem, useful output energy is the amount of energy stored in the battery, which is 45 kilojoules. We have to convert this into joules by multiplying with 1000. The total input for the process of charging battery has to be calculated. In this car, initially the car has a kinetic energy, so we can calculate the kinetic energy of the car, initial kinetic energy of the car, using half mv squared. Where half, and where the mass would be 1800, velocity of the speed would be 14 squared. However, part of this kinetic energy also converts to gravitational potential energy due to the fact that car is moving upward. So we can calculate the amount of gravitational potential energy, change in gravitational potential energy of the car during this process using mgh. That would be 1800 multiplied by 9.81 times the change in vertical height is 0.76 meters. Total input for the process of charging battery must be calculated using the difference of kinetic energy and gravitational potential energy. If you do the calculations, you get the kinetic energy to be around 176,000 joules. Gravitational potential energy is 13,400 joules, and the difference and the ratio of the efficiency would be 0.277. Let's move on to question 15. A builder uses bricks to build a wall. As the wall gets taller, the force on a brick at the bottom of the wall increases. Force compression graph for this brick is shown. Determine the increase in elastic strain energy in the brick as the force increases from 85 newtons to 140 newtons. In a force compression graph or force extension graph, gradient represent constant of elasticity, and area under the graph, if you calculate the area under the graph, that gives us the amount of elastic strain energy that is stored on the material. Therefore, to answer this question, we can calculate the energy under the graph. However, you should be careful. We are not going to calculate the total area. We just have to calculate the area under the graph between 85 Newton and 45, 140 Newton. So if you mark 85 Newton along the y-axis, we can find out the corresponding compression. Also, we can mark 140 and then find out the corresponding compression for that. If you calculate the area under the graph of this section, which is a trapezium, we can calculate the elastic strain energy. So the corresponding compressions are 60 nanometers for 85 newtons and approximately 97.5 nanometers for 140 newtons. Then you can use the formula for a trapezium to calculate the energy, which is half times sum of the parallel sides, which is in this case 85 plus 140 times the perpendicular distance between the two parallel sides, which is given by 97.5 minus 60. Very important, should be careful, the compression is given in nanometers, so it should be converted to meters by multiplying with the factor of 10 to the power minus 9. So our final answer would be 4.28 times 10 to the power minus 6 joules. Part B, the brick undergoes elastic deformation. What is meant by elastic deformation? So the definition of elastic deformation is that the material returns to its original size or the shape when the force is removed.